welcome back to StudyOnion, the channel where I'm trying to teach you more about GCSE astronomy in a fun, unique and innovative manner. Today we're going to start topic 3, the Earth, Moon and Sun system, and begin by talking about spring and neap tide, as well as the precession of the Earth's axis. Let's get started! So tides were first explained by Newton's laws of gravity in his book Principia. So when we talk about tides and gravity, we need to think about three main celestial objects: the Earth, the Sun and the Moon. Let's just talk about the Earth and the Moon and how they impact each other to start off with. The Earth and the Moon create a gravitational pull on each other, resulting in both of them orbiting each other. As the Earth is so much more massive than the Moon, and by massive here I mean higher in mass, the centre of the orbit is much closer to the Earth than it is to the Moon. Now, this gravitational pull slightly elongates the spherical shape of both of these celestial objects, and that's why they're both more oblate spheroid in shape. This change of shape is quite unnoticeable, but an object that is much more easier to distort is water. And in the form of tides, we see this water getting distorted by the gravitational pull of the Moon on the ocean. Now, this just shows that the ocean bulges and creates this high tide due to the effect of the Moon. Now, you may be asking, why is there a high tide on the opposite side of the Earth in relation to the Moon? Well, this is because it's an effect created by the centrifugal force, which is actually not a proper force, but it's an effect which is caused by the Earth orbiting around the centre of gravity between it and the Moon. So to explain this a little bit further, while the Moon does orbit around the Earth is also affected by the Moon, and this causes it to have a tiny orbit. This tiny orbit creates this centrifugal force, which results in a high tide on the other side of the Moon. Okay, so let's take a little look at a video clip which will explain what I was talking about a little bit further. Now, let's talk a little bit more about spring and neap tides. Spring tides, or otherwise known as king tides, which should not be confused with the spring season because they have no relation to spring, are basically when, during the periods where the Moon is aligned with the Sun on either side of the Earth, so a new or a full moon, the high tides are slightly higher due to the combined gravitational pull of the Sun and the Moon, both adding up to create a higher tide, and the low tides are slightly lower in relation to the higher tides. When the Sun and the Moon are at right angles to each other, the effect of the Sun and the Moon almost balances out, decreasing the height of the high tides and increasing the height of the low tides, and these happen at both first and third quarter. Now, let's talk a little bit about precession. So precession is this sort of gyroscopic movement of the Earth's axis, and this happens about every 2,600 years. So if we look at this first picture, we can see the kind of centre of the Earth's axis moving around in this circle, and the animation on the second part of the slide demonstrates this, where the rotation of the Earth causes the rotation of the axis. And all moons and planets do experience precession. Precession is not only limited to the Earth, although in astronomy we only typically study it for the Earth. Now I'm just going to play this little animation where you can see where the centre of the axis on the Earth should be and where it is due to this gyroscopic precession. Okay, so let's take a little look at a video clip which will explain what I was talking about a little bit further. So, if we talk about the evidence for this axial precession, so this movement of the Earth's axis, we can begin by talking about the changing pole star. So the current pole star is Polaris, but this has not always been the pole star, and it will not always be the pole star. And this pole star changes because the axis will point to a different star. This is also the changing location of the equinoxes. And this is where the ecliptic, or the Earth's path around the celestial sphere, crosses the celestial equator. So these are moving slowly westward, so that the first point of Aries, which is the point where the celestial equator and the ecliptic meet, is no longer in Aries, but is actually in Pisces and is heading towards Aquarius. The third piece of evidence for this is the misalignment of ancient monuments and temples. So many of these structures were built in the ancient times where astronomy was particularly useful, and we'll study more about this in topic 4, time and the Earth, Moon, Sun cycle. But these monuments were used to predict many things, and many such monuments and structures were aligned to particular stars, Sirius. And by knowing the rate of precession, which is about 1.4 degrees per century, astronomers can approximate the dates of these monuments. So, to summarize, tides are created by the gravitational pull of the moon on the Earth, as well as the effect of a centrifugal force which is caused by the Earth's orbit around the centre of gravity between the Earth and the moon. Spring and neap tides are when the moon and the sun are both aligned at a full moon or a new moon, which creates slightly higher high tides and slightly lower low tides. The neap tides are when the moon and the sun are at right angles to each other, causing the effect of the sun and the moon on the oceans to balance out, decreasing the high tides and increasing the low tides, and these happen at first and third quarter. Precession is the gyroscopic movement of the Earth's axis, which happens every 26,000 years. All moons and planets experience such cycles, but the rate of precession of the Earth is 1.4 degrees per century. Evidence for this axial precession include the changing pole star, the changing location of where the equinoxes align, so this is where the ecliptic crosses the celestial equator, as well as the misalignment of ancient monuments. Hopefully that helps you learn more about GCSE astronomy and specifically tides and precession. We'd love to see you again here next time. Bye!